Right guys, now we understood the logic of differentiation, that we separate these functions and get them one at a time and differentiate. Let's do more problems and get used to this methods, right? So here on the board I have a problem like x plus 2 and cosecant x by x squared plus 1 whole squared. So I can take this whole thing as numerator term and denominator term. So how should I start the problem? I will use quotient rule first. It goes like denominator into differentiation of numerator minus numerator into differentiation of denominator, the whole thing by d squared. So that's what we have, right? That's a formula basically. So in this case that will be the differentiation of n by d. Now go ahead, who is denominator? This guy is x squared plus 1. We get this differentiation of numerator, which is I can say is x plus 2 and a cosecant x. Yep, this whole thing. Now minus sign numerator, that is x plus 2 and a cosecant x. All right, yeah, into differentiation of denominator, that is x squared plus 1. So what I have, the whole thing divided by x squared plus 1 the whole squared. So that's my denominator whole squared. Cool. What next thing I have to do? We'll see. Go back to this. I have x squared plus 1. I'm not touching this guy because there's no differentiation sign behind this. The next thing is I have a differentiation sign, but I have two functions. So I got to use product rule here. It looks like u into v rule. So it goes like, open a bracket, that is x plus 2 in a differentiation of the second function, that is cosecant x. First function into differentiation of second function plus cosecant x into differentiation of x plus 2. Why am I doing this? I can see here it looks like uv rule. So I can say that if y is equal to u into v, the answer is what? dy by dx is what? I can take u into dv by dx plus v into du by dx. So it means what? If I have two functions coming up together, keep the first function, differentiate the second guy, plus keep the second guy, differentiate the first guy. That's it. So I'm using the same thing. First guy differentiate second, plus second guy differentiate the first. That's it. Now that part is done. So I have a minus sign here, then I have x plus 2 into cosecant x. I have nothing to differentiate because there is no differentiation sign here. Let it go like that. Now I have differentiation of x squared plus 1. So let me do it in the next step. So the whole thing divided by, I have x squared plus 1 the whole squared. Now see, where all do we find differentiation signs? I find it here, and there's one single guy. I can differentiate this. I find it here, that is x plus 2. I can differentiate this, single function almost, x plus 2. Here again is a single function, right? X squared plus 1. I can differentiate as 2x and as 0. That's it. So I can see that here also I could find these three guys who were together with product and quotient rule and made them come single. This guy is single, this guy is single, and that guy is single. Very simple. Go ahead. Now differentiate. See what is this? This is very easy. X plus 2. How do you differentiate this guy? That is minus cosecant x cot x. We guys should know the formulas. If you don't know, just click on the right side. You have a formula list. You can see that. Right. Plus. Then you have cosecant x into differentiation of x plus 2. Differentiation of x is 1. 2 is 0. So we don't write that. Cool. Minus x plus 2. Cosecant x. Now how do you differentiate this guy? That is 2x. Nothing much. Alright, that's it. The whole thing divided by, I have x squared plus 1 the whole squared. So that's it. I differentiated once here. This guy, and that guy. So I can see in the whole problem, you're just differentiating one function at a time. And what are we doing here is basically separating these functions. Keep that in mind. I'm stressing this point. This is what you should learn in differentiation. All right.